For this problem, we are required to determine the value of EIY at the pre-end. Step number 1. Compute the value of reaction at point A and point B. Para makuha yung value ng RA, mag-take tayo ng summation ng moment sa point B by taking all clockwise rotation as positive is equal to 0. RA, magro-rotate yan ng clockwise sa point B with a moment arm of 4 meters plus yung 120 Newton meter na load sa overhang, magkikreate din yan ng clockwise rotation sa point B, 120 times length 2, at ang moment arm ng load na yan hanggang point B is 1. Next naman is yung 120 Newton per meter na load, magro-rotate yan ng counterclockwise rotation sa point B, kaya negative, 120 times length 2, at ang moment arm niyan hanggang point B is 3, equal to 0. By computation, the value of RA is equal to 120 Newton. By taking the summation of all forces vertical is equal to 0, RA plus RB minus 120 times 2 minus 120 times 2 is equal to 0. Meron na tayong value ng RA, 120 Newton, plus RB minus 480 is equal to 0. Therefore, the value of RB is equal to 360 Newton. Step number 2. Draw the possible shape of the elastic curve of the beam. Dahil magkasing length lang naman yung uniformly distributed load, feeling ko, ganito yung maaaring maging itsura ng elastic curve ng beam. Step number 3. Draw a tangent line on the elastic curve taken at any support. Para sa problem na to, sa point B ko pipiliin na mag-drawing ng tangent line. Pero pwede mo din naman na gawin na sa point A mag-take ng tangent line. For this problem, yung point B yung pipiliin ko na axis na mag-a-act as peak support. At doon ko imo-moment lahat ng load ng beam. Hindi ngunit sa point B ako nag-drawing ng tangent line, yun na yung gagamitin ko na axis na mag-a-act as peak support. Pwedeng sa point B ako mag-drawing ng tangent line, then sa point A ako mag-take ng axis na mag-a-act as peak support kapag nag-drawing na ako ng moment diagram by parts. Pwede din naman na sa point A ako mag-drawing ng tangent line, and sa point B ako mag-take ng axis na mag-a-act as peak support kapag magdo-drawing na ako ng moment diagram by parts. Kapag yung point B yung pinili kong axis na mag-a-act as peak support at pinerform ko na yung moment diagram by parts, ganito yung magiging itsura ng load ng beam. Kung titingnan natin yung load for segment AB, walang available na moment diagram kapag ganyan yung load. Kailangan continuous yung uniformly distributed load hanggang sa peak support. So, kailangan gawin natin siyang continuous. Kapag ganyan yung naging load ng beam, meron ng available na moment diagram. Kaso nagdagdag tayo ng load kaya kailangan ibawas din natin siya. Ito naman ngayon yung magiging itsura ng binawas natin na load. Ito ngayon yung magiging itsura ng beam kung yung point B yung pipiliin natin na axis. Kailangan lahat ng load ng beam ay continuous hanggang sa point B. Isa-isahin na natin ngayon i-drawing yung moment diagram by parts. Unahin natin i-drawing yung moment diagram ng reaction sa point A. Dahil concentrated load yung reaction sa point A at upward yung direction, kaya naman yung moment diagram ng reaction sa point A ay nasa positive side ng moment diagram. At kapag iminoment natin yung RA sa point B, equal yon sa 120 times moment arm 4, which is equal to 480. Ang next na kunan natin ng moment diagram is yung downward load na 120 Newton per meter na uniformly distributed load sa segment AB. Dahil downward load yan, kaya nasa negative side ng moment diagram. At kapag iminoment natin yung 120 Newton per meter na load sa point B, equal yon sa 120 times length 4 times moment arm 2, equal to 960. Ang next naman na kunan natin ng moment diagram is yung upward load na 120 Newton per meter. Para hindi magpatong yung moment diagram na ginagawa natin, pwede tayong gumawa ng panibagong axis. Ito naman ngayon yung itsura ng moment diagram ng upward load na 120 Newton per meter load. At kapag iminoment natin yung load na yan sa point B, equal yan sa 120 times length 2 multiplied by moment arm, which is 1, and that was equal to 240. Yung moment diagram ng 120 Newton per meter load, since uniformly distributed load yan, kaya naka second degree yung curve niyan sa moment diagram. Importante na ilagay natin yung degree ng curve sa moment diagram kasi kapag meron na tayong triangular load, baka malito tayo kung second degree ba siya or third degree. Yung last na kukunan natin ng moment diagram is yung uniformly distributed load sa segment BC. At kapag iminoment natin yung load na yan sa point B, equal yan sa 120 multiplied by distance 2 at moment arm hanggang point B ay 1, which is equal to 240. And this curve is in 2-degree curve. Step number 5. Compute the value of deviation of point A relative to a tangent drawn to the elastic curve at point B and the value of deviation of point C relative to a tangent drawn to the elastic curve at point B. Niredraw ko yung beam na ang kita lang ay yung dimension, elastic curve at tangent line. Then, inexage ko ng konti yung itsura ng elastic curve. Kasi magpapatong-patong na yung mga values na ilalagay ko kapag inilagay ko pa doon sa original na figure. This distance is the deviation of point A relative to a tangent drawn to the elastic curve at point B. This distance is the deviation of point C relative to a tangent drawn to the elastic curve at point B. Yung distance naman na ito is yung deflection at point C. Para sa deviation of point A over B, ang formula niyan ay equal sa 1 over EI multiplied by the area bounded from point A to point B multiplied by bar XA, kung ano yung nandito na letter. Para naman sa deviation of point C over B, ang formula niyan ay equal sa 1 over EI multiplied by the area bounded from point B to point C multiplied by bar XC, kung ano yung letter na nasa ibabaw. Looking at the formula of our deviation, lahat ng area bounded from point A to point B, kailangan natin ng distance ng bar XA, or yung distance ng centroid ng moment diagram measured hanggang sa point A. At para naman sa lahat ng area bounded from point B to point C, kailangan natin ng distance ng bar XC, or yung distance ng centroid ng moment diagram measured hanggang sa point C. Yung distance ng centroid ng triangle measured hanggang sa point A ay equal sa 2/3 ng 4, which is equal sa 8/3. Next naman is yung second degree curve sa negative side. Ang distance ng centroid nun hanggang sa point A ay equal sa 3/4 ng 4, which is equal to 3. Para naman sa second degree curve sa positive side, yung distance ng centroid nun hanggang sa distance lang na to ay equal sa 3/4 ng 2, which is equal to 3/2. At para naman sa moment diagram sa segment BC, yung distance ng centroid ng second degree curve hanggang point C ay equal sa 3/4 ng 2, which is equal din sa 3/2. Dahil kumpleto na yung mga value na kailangan natin, pwede na natin makompute yung value ng deviation of point A over B. Equal yon sa 1 over EI. Yung triangle muna, ang area niya ay equal sa 1/2 multiplied by length, 4, times intensity, 480, multiplied by bar XA, equal to 8/3. Minus yung second degree curve na nasa negative side, ang area niya ay equal sa 1/3 ng length, 4, multiplied by intensity, 960, multiplied by bar XA, equal to 3. Next naman is yung second degree curve na nasa positive side, plus, ang area niya ay equal sa 1/3, multiplied by length, 2, intensity, 240, multiplied by bar XA, ang bar XA na niyan ay equal sa 2 plus 3/2. By computation, the value of deviation of point A over B is equal to negative 720 Newton meter cube over EI. Next naman is yung deviation of point C over B, equal yon sa 1 over EI, multiplied by the area. Dahil nasa negative side, ilagay na natin na negative, 1/3 ng length, 2, times intensity, 240, multiplied by the bar xc, which is equal to 3 halves. By computation, the value of deviation of point C over B is equal to negative 240 Newton meter cube over EI. Ano yung ibig sabihin ng negative sign sa deviation of point A over B? Ang ibig sabihin lang nun ay nasa ilalim ng tangent line yung elastic curve. So, ibig sabihin, tama yung drawing natin. Same as dun sa deviation of point C over B. Kung nagkataon na positive yung value ng deviation of point C over B, ibig sabihin yung elastic curve ay nasa ibabaw ng tangent line sa point C. Step number 6. From the relations between similar triangles, determine the value of deflection at point C. Kung mapapansin natin, itong horizontal beam natin at tangent line ay makakabuo ng similar triangle. At yan yung gagamitin natin para makuha yung value ng deflection sa point C. By performing the similar triangle or ratio and proportion, the value of deviation of point A over B over 4 is to deflection at point C minus deviation of point C over B over 2. Dito sa ratio and proportion, hindi na natin isasama yung sign ng deviation na nakuha natin kasi value na lang yung kailangan natin at na-consider na kasi natin yung direction ng mga deviation. The value of deviation of point A over B is equal to 720 over EI over 4 is equal to the deflection at point C minus deviation of point C over B, which is equal to 240 over EI over 2. Kapag pinag-cross multiply ko yung magkabilang side ng equation, pwede ko i-simplify yung value ng deflection sa point C as equal to 720 over 2 EI plus 240 over EI. Then the value of deflection at point C is equal to 600 over EI Newton meter cube.